Hey y'all, today is May 17th and we are going over a little geometry review to help you understand what you might see on your geometry test on Thursday. So let's go ahead and get started. Our first topic is scale drawings. We solve these by setting up and solving a proportion. And remember, a proportion is two fractions that equal to each other that we solve by cross multiplying. So number one, says a large map has a scale of 1.5 inches equals 40 miles. If two cities are 1.5 feet apart on the map, what is the actual distance between them? Well, I'm going to start with this information right here. And that's what I'm going to use for my first fraction. Okay, now I don't like fractions in fractions, so I'm going to change this 1.5 to a decimal. 1.5 inches over 40 miles. Now, the reason I like to include my units is because I have to be consistent. In my second fraction, I need inches on top and miles on the bottom. Now, the other important piece of information here is 1.5 feet. I don't have either inches or miles, okay? But I know that the two cities are 1.5 feet apart on the map. And I know that the map is my inches, so I need to convert that to inches. So the way I do that, I know that there are 12 inches in 1 foot. So I'm just going to multiply 1.5 times 12. 1.5 times 12 is 18. So I know that that's 18 inches. So 18 inches goes on top, and we put our x on the bottom. We're trying to find that x. So I cross multiply. 1.5 times x is 1.5x. And I set that equal to 40 times 18. And 40 times 18 is 720. Now, to get that x by itself, divide by 1.5 on both sides. So x equals 480 miles. Okay. Number two, students in Mr. Morgan's math class were asked to produce a drawing of themselves using the scale 0.75 inches equals 2 feet. Travis is 5 foot 8 inches tall. How tall will his drawing be? Okay. So what I notice right off the bat is 5 foot 8 inches. I need to convert that to all the same unit. So it would be easiest if I made that all inches. So the way I do that is I focus on the 5 feet first. Well, 5 times 12 I know is 60 inches. And then I still need to add the 8 inches. So I know that that's going to be 68 inches. Okay, so 68 inches is going to help me out. Now, in the scale that's given to me initially that I would use to make my first fraction, I have 0.75 inches equals 2 feet. And normally I would set that up as 0.75 inches over 2 feet. But think about it. We know the drawing is 0.75 inches and the real life actual is 2 feet. Well, in real life actual, Travis is 68 inches tall. So I've just made this inches. So could I make that inches? I sure could. The way I would do that, 2 times 12, because there's 12 inches in 1 foot, equals 24. So I'm actually going to change this to 24 inches. And now I'm going to set that equal to my second fraction. We know that this is the drawing. And this is the real life. So real life measurement of 68 inches needs to go on the bottom. And I put my x on top. So now I can cross multiply. 24 times x is 24x equals 0.75 times 68, which is 51. Divide by 24 on both sides. So x equals 2.125 inches. That's how tall his drawing will be. Okay, moving on to number 3, part 2, triangles. So classify each triangle by its angle measurements. So I'm actually going to start with B. What I notice in B is I've got a 90-degree angle, a 36-degree angle, and a 54-degree angle. This 90-degree angle is key. Because that's a 90-degree angle and I have one angle that equals 90 degrees, I know that this is a right triangle. Okay, let's look at C. 28 degrees, 104 degrees, 48 degrees. That 104-degree angle is key. I have one angle that's greater than 90 degrees. that means that this is an obtuse triangle. And lastly, 46 degrees, 49 degrees, 85 degrees. I went back up to A. They're all less than 90 degrees. And when they're all less than 90 degrees, that's an acute triangle. Okay, now D is important. You need to know D to be successful on this test. The sum of the angles in a triangle is always 180 degrees. That means that angle 1 plus angle 2 plus angle 3 equals 180 degrees. Okay, let's look at number 4. Solve for x. So I know that angle 1 plus angle 2 plus angle 3 equals 180 degrees. So I'm just going to write an equation to say that. So we have 44 degrees plus 6x minus 12 degrees plus 4x plus 8 degrees equals 180. Now I have some like terms that I can combine here. So some like terms, let's start with our x's. 6x plus 4x is 10x. And then the other numbers that are just plain old numbers without x's, I can also combine. So I have 44 minus 12 plus 8. And when I put that into my calculator, I get a positive 40. So plus 40 equals 180. Now this is a normal two-step equation that I can solve. I'm going to subtract 40 on both sides. So we have 10x equals 140. To get that x by itself, divide by 10 on both sides. So x equals 14. Okay, let's move on to our third section. We've got angle relationships. So you do need to know some angle relationships. So number 5, answer each question using the figure. What is the value of x? Well, let's talk about this figure first. I have one angle here, a second angle here, and a third angle here. And all three of those angles make this straight line. So all together, they add up to 180 degrees. Now, let's talk about this first angle here. What's important about that angle is this little square. It tells me the value of that angle. When I see that square, I know it's a right angle. So that angle is 90 degrees. Okay? So I know that one angle is 90 degrees, one angle is 8x, and one angle is 44 degrees. And we want to figure out what is the value of that x right there. Well, I know that because this angle here is 90 degrees, that means that these two angles together are also 90 degrees. So I could write an equation. We could say 8x plus 44 equals 90. To get that x by itself, this is a normal two-step equation. I'm going to subtract 44 on both sides. So I have 8x equals 46. To get that x by itself, divide by 8 on both sides. So x equals 5.75. So that is my answer for A, 5.75. Now, what is the measure of angle GFH? Well, angle GFH, we're talking about this angle here. This one that is, okay. Well, to figure that out, I'm just going to plug in 5.75 for x. So we have 8 times 5.75, and when I plug that in, I get 46. So 46 degrees is that angle measure. Okay, so now I know the angle measure for all of these angles. So we have one angle that's 90 degrees, one that's 46 degrees, and one that's 44 degrees. So in C, what is the measure of angle DFH? So angle DFH, we're talking about these two angles combined. That makes that one obtuse angle. So the way I figure it out is I take 90 degrees and add 46 degrees. So 90 plus 46 is 136 degrees. And in D, what kind of angles are angle GFH and angle HFE? So GFH, let's change to my little highlighter thing. GFH is here, and HFE is here. So what kind of angles are those? Well, they're right next to each other. What do we call angles that are right next to each other? We call them adjacent. They are next to each other. Okay? Now also, a lot of people have been trying to say today that they are right angles. And together, they make a right angle. That means that together, they add up to 90 degrees. What do we call that? We call that complementary. So I'm just going to abbreviate that as comp. Complementary angles add up to 90 degrees. So angle GFH that I have highlighted in blue and angle HFE that is 44 degrees, those angles together are complementary angles. They add up to 90 degrees. They're also adjacent. They're next to each other. Okay? Now let's look at number 6. What is the value of x? Well, first of all, you need to know what angles we're looking at. We're looking at this angle here, which is 6x plus 8 degrees, and this angle here, which is x plus 18 degrees. So how could I classify those angles? They are adjacent because they're next to each other. But there's another way I could classify them. So let me show you those angles again. This angle here and this angle here. Do you see that together they form this straight line? When angles form a straight line together, they add up to 180 degrees. What do we call that? We call that supplementary. Okay, so those are also supplementary angles. That helps me set up my equation. So because they're supplementary, I know they add up to 180 degrees. So we have 6x plus 8 plus x plus 18 equals 180. Now I'm just going to combine like terms. So 6x plus x is 7x, and 8 plus 18 is 26. And I still set that equal to 180. Now I have a normal two-step equation that I can solve. So I'm going to subtract 26 on both sides. So I have 7x equals 154. To get that x by itself, divide by 7 on both sides. So x equals 22. Okay, let's move on to the fourth section of our test, circumference of a circle. So, circumference of a circle. There are two formulas for that. You could use c equals 2 times pi times the radius, or you could use c equals pi times the diameter. So it doesn't matter which one you use. So number 7, find the circumference, use 3.14 for pi. Well, what I notice is that this measurement right here goes from one edge to the center of the coin. So I call that a radius. So I think it's best to use c equals 2 times pi times the radius here. Now remember, for pi, I always plug in 3.14, so 2 times 3.14 times 0.42. And when I put that into my calculator, I'll get my answer. So when I put that into my calculator, I get 2.6376 inches. And I just want to show you that that's what you get. So let me go to my calculator real fast. Let's clear all that. So we have 2 times 3.14 times 0.42, and you get 2.6376 inches. Okay? So now let's move on to number 8. You have 110 inches of yellow ribbon. The diameter of an oak tree is 38 inches. Do you have enough yellow ribbon to wrap around the oak tree? Explain. Okay, so we're finding the circumference here. And we were given this very important piece of information, that the diameter is 38 inches. Okay, so because we were given the diameter, I'm actually going to use this formula this time to find the circumference. So c is pi times the diameter. You could find out what the radius is, but you don't have to here. So we know 3.14 times 38 will give us the circumference. So I'm just going to go put that into my calculator. So we have 3.14 times 38, and I get 119.32. So 119.32 inches is our circumference. Now, that's not our answer because we have to answer if we have enough yellow ribbon to wrap around the oak tree. Well, we only have 110 inches. And I know that 119.32 is greater than 110. So do we have enough? No. We do not have enough ribbon to wrap around that oak tree. Okay, let's move on. So now we're talking about area of a circle. So area of a circle, there's just one formula, A equals pi times the radius squared. Now I want to be very clear here. Radius squared means R times R, not 2 times R. So be very careful with that. So number 9, we have a basketball court, and it says the center circle is identical to the circle formed by the free throw line. Find the area of the center circle. Use 3.14 for pi. So basically what it's saying is that all 3 of these circles are identical. And we're finding the area, how much space that center circle takes up. Now it's important to know that it's identical to the circle formed by the free throw line because we have this measurement here, 12 feet. Now, why is 12 feet significant? Well, it's significant because that is my diameter. So if my diameter is 12 feet, can I figure out my radius? My radius is just half of that, so it's 6 feet. Okay, so area is pi times the radius squared. So we have 3.14 times 6 squared. Now I'm just going to go put that into my calculator. So 3.14 times 6, and on this Desmos calculator, I hit that A squared button underneath main to square that, and I get 113.04. So the area is 113.04 square feet. Okay, now we're going to find the area of this little smiley face circle. So why is that 4.1 centimeters significant? Well, it goes from one edge to the center, so I know that that right there is my radius. So area is pi times the radius squared. So we have 3.14 times 4.1 squared. I'm just going to go put that in my calculator to figure out what I get. So back to the calculator. 3.14 times 4.1, hit that A squared button to square it, and I get 52.7834. So 52.7834, and my unit is square centimeters. Okay, moving on, cross sections. So cross sections, we're slicing a 3-dimensional figure either parallel or perpendicular to the base, and we want to know what shape we're going to see when we open it up. So in number 11, I have a triangular pyramid. The reason I know it's a triangular pyramid is because at the bottom here, I have a triangle. So it's a triangular pyramid, and I'm slicing it parallel to the base. It's like a horizontal slice, and whenever I slice parallel to the base, I know that my cross-section is the same as my base. So, what is my cross-section? Well, it's going to be a triangle. Okay, number 12. Here I have a sphere, a round sphere, and we are slicing it parallel to the base, but no matter how I slice a sphere, whether it's parallel to the base or perpendicular to the base, if I open that, all I'm going to see is a circle. Okay, moving on to surface area. So number 13, surface area of a triangular prism. Now remember, triangular prisms, my base is what I have 2 of, and I have 2 triangles and 3 rectangles. So my base is this triangle in front and the identical triangle that's in the back right here, right? So let's call that front and back. And I want you to recognize that the front and back are my base triangles, right? So I'm using the area for a triangle formula, 1/2 times base times height. So we have 1/2. Now what is the base of that triangle? The base of that triangle is 6, and the height is this measurement right here, which is 4. So 1/2 times 6 times 4. Well, when I put that in my calculator, I get 12. So the front and back area is 12. Now let's find the left and the right. So I consider the left and the right this rectangle right here and the one that's identical to it on the other side, right? So that's what we're looking at. So let's call it left and right. And we know it's a rectangle, so that helps us with our area formula. It's length times width. So we're talking about this shape here. My length is 7, my width is 5. So 7 times 5 is 35. Okay, now I just have one more area to consider. Well, it's sitting on this rectangle here. Do y'all see that? Let's see if I can make that a little bit better. I don't think I can. Okay, but y'all understand it's sitting on that rectangle on the bottom, right? So there's a bottom to the figure, and it's a rectangle. Well, what are the dimensions of that rectangle? Well, it's 6 meters by 7 meters, right? So 6 times 7 is what? It's 42. So now I just need to add all this up. Now I want you to be careful because there are two sides that have an area of 12. So I have to double that. 12 times 2 is 24. There are two sides that have an area of 35. So I have to double that. 35 times 2 is 70. So surface area is going to be 24 plus 70 plus one side has an area of 42. And when I put that into my calculator, I get 136. 136 square meters. Okay, now let's find the surface area of this rectangular prism. I could do it the same way I just did the triangular prism, or I could use my formula. There is a formula for surface area of a rectangular prism. It is 2 times length times width plus 2 times length times height plus 2 times width times height. Okay? So I'm going to use that formula. It doesn't matter how I label my numbers as long as one of them is length, one is width, and one is height. So I'm going to say that this 6 right here is my length, the 9 is my width, and the 3 is my height. Okay? So we have 2 times 6 times 9 plus 2 times 6 times 3 plus 2 times 9 times 3. So 6 times 9 is 54. So I have 2 times 54 plus 2 times 6 times 3, which is 18, plus 2 times 9 times 3, which is 27. And I'm just going to continue to simplify. 2 times 54 is 108. 2 times 18 is 36. And 2 times 27 is 54. And 108 plus 36 plus 54 is 198. So I get 198 square centimeters. That's my surface area. Okay? Now volume. So moving on to volume. Number 15, how much water is needed to fill the aquarium? Well, we're asking what is the volume of this figure? So volume, remember, is always going to be big B times H. So I've got to figure out the area of the base. The area of the base, because this is a rectangular prism, is this rectangle that this figure sits on. So the area of the base, because it's a rectangle, is length times width. So length times width. So for a rectangular prism, volume is going to be length times width times height. Okay, so volume is, let's say that 4 is the length, 2 is the width, and 2 is the height. Volume is going to be 4 times 2 times 2. I know that 4 times 2 is 8, times 2 again makes 16. So the volume is 16 cubic feet. Okay? Now in part B, we're told that there are 7.5 gallons in 1 cubic foot. How many gallons of water does the aquarium hold? Well, all I'm going to do is multiply 7.5 times 16. And I'm going to go put that into my calculator to figure out what I get. We have 7.5 times 16, which is 120. So that fish tank will hold 120 gallons of water. Okay, last one, number 16. Find the volume. This time we have a triangular prism. So I know that the formula for volume is big B times H. Remember, this big B right here represents area of the base. And the base is what I have 2 of, and I have 2 triangles. So we're looking at this triangle here in front. So I need to figure out the formula for, or the area of that triangle. So we have big B is 1/2 times the base times the height. Well, the base of the triangle times the height of the triangle. The base of the triangle is this right here, and the height is that right there. So we have 1/2 times 3.6 times 5. Right? So I'm just going to put that into my calculator. So we have 1/2. I'm going to do that as 0.5 times 3.6 times 5. And I get 9. So 9 is the area of the base. So big B equals 9. Well, once I know that, I need to know how far apart my triangles are. Well, they are separated by 3.5 centimeters. So 9 times 3.5 will tell me my volume. So I'm just going to go to the next line, take that answer, so I just copied it, and then multiply that times 3.5, and I get 31.5. So my volume is 31.5 cubic centimeters. That is the end of this review. Don't forget, your study guide is due tomorrow. Have a great day.